thank you for inviting me here. I appreciate it.
Yeah, thank you for joining in, Wajahat, because we are just like on time and just like I have done all the introduction and things like that. So please proceed with your presentation and today's agenda. Over to you. Thank you so much for joining in. I'll be here off stage.
Hello, everyone. My name is Careem, and I'm very excited to be here. And I'm currently live from Pakistan, Karachi. And if you are a Muslim, happy Ramzan. So today I'm going to talk about mostly about Kotlin. This is not a completely technical talk. This will be a more of like overview of Kotlin from beginners to intermediate, some advanced topics I would also dig in. But this will be specifically about theoretical perspective, and there will not be much about the coding perspective. But yes, Kotlin in a whole is uh, very technical programming language. So yes, you can expect some, you know, going into the deep woods too. So yeah. So, so I am a Google developer expert in Android for like last 2 years now. At this time, I'm the only one in Pakistan in Android, and I have been working in industry for more than 8 years now. And I have been very much active in open source, and I have done some very good writing in worldwide published 2 books, and there are like 100 plus articles around the internet written by me, and most of them are about Android development. So chances are that you must have seen me on internet, on Twitter, and other places at some point. So if not, then I'm happy to meet some new faces and meet some new people. So yeah, I'm mostly active on Twitter. So if you have anything related to Android, or if you want any kind of advice, or if you want to just connect and say hello and get a coffee or something, so please reach out to me on Twitter and LinkedIn. Those are the places which I'm very active. So you can check my website, wajadkareem.com. It has like lots of articles and stuff, and there is some very interesting stuff coming up soon. I'm working with some more people to do some collective work, so stay tuned. So so this is how what I think about everything in my life, whether it's Kotlin, whether it's Android, whether it's my personal life, whether it's marriage or anything. So it's all about how much you are into a comfort zone. So the thing I say is that if you are swimming and you are not drowning, then chances are that you are stuck in a comfort zone. At that point, you actually need to get into some deep water, rough water, and start learning to swim there in that uncomfortable position where you are not habitual and where you are not getting used to it. So that's where real growth comes in. That's where real skills come in. That's where real learnings come in. So, and I understand that this is not a cup of tea for everyone. It requires a lot of courage, and it requires a lot of confidence, and it requires a lot of risk to leave the comfort zone and go into the uncertainty. Now you might be wondering that we are here to talk about why we are talking about comfort zone. So the point of adding this slide in the very start was that I hear this question a lot from a lot of students and from a lot of people whom I meet at various events and online. Uh, every time they ask me about why should I learn new language, why should I learn Kotlin, why should I learn any new framework. Like for example, in my case, I was learning, I was doing Adobe Flash for like years. Like I was so good at it, like I could use it with my eyes closed. And then at some point, I realized that Flash is going to be dead. So I and then moved to Android and moved to Kotlin. So So when I hear this question that why should they learn anything new if they have been doing something already and they are very good at it, so that's where I say that uh, there is any kind of skill, it's not going to be a waste in some point. You must have heard that debate about Steve Jobs, where he said that it's all about connecting the dots, looking into the past and see how all those things you worked on, maybe coincidentally, maybe randomly, maybe someone asked you to, but they all connect at the end and they create a path for you, for your trajectory, for your career, for your life. So that's how life is. That's how comfort zone is all about. So, so you shouldn't need to think about that. What you should need to learn, whether it's about you see that there is a heavy scope of Web3, or there is a very large scope of Flutter or Kotlin multiplatform or anything. It doesn't matter. Technology is coming and going, coming. So we live in a world where uh, at night we do something, and when we wake up in the morning, that thing is already replicated and something new is coming up. So learning is our true skill here to survive in this industry and to move forward. So that's my answer, and that's where this comfort zone comes in. So what kind of modern languages we have at this point? There are a lot of modern languages. Like if the term modern language is something like we had machine language, then we had structural programming like C and Boolean and those kind of languages. In between, we had assembly language. So after structural, we got the concept of object-oriented programming, and then came C++ and Java and C Sharp and those. And then we got into a new kind of programming that was called reactive programming. It started from Facebook's React Native and RX framework. And then every language started doing that kind of thing. So we got to know about Kotlin, we got to know about Swift and Scala, and a lot of other languages would support reactive. And the age you are living in at this time, reactive is going to be a thing of past, and next upcoming shiny diamond is going to be um, I forgot the name. Okay. So the shiny thing is about going to be okay, there is a framework about functional programming. Yeah, functional programming. So you must have seen Arrow framework and those kind of things at some point. And if you are into the Kotlin, then that's the next level of generation. It hasn't got any mainstream yet, but you can assume that at this point, reactive programming is everywhere, around every language, every framework, every device, every target, and everything, literally. So I'm going to pick Kotlin from all these languages and give you a historical perspective on how Kotlin evolved and why it is a good language and why it is performs better in terms of comparison with other languages, and why you should consider it as your next learning skill. So this is the whole agenda of this slide. So Kotlin started in early 2016, and at that time it was not completely open, but some people knew, and it was not completely, operating in Android and Java frameworks, but early adopters were very highly into it. And then about a year later, Google actually made it official because they realized that Kotlin is making a lot of things easier for Android developers. And once Google made it official for Android, it just skyrocketed and it just boosted up. So 2 years later, Google shared that Kotlin is number one fastest growing language, and there are more than 50% Android developers which are using Kotlin as their primary language. And now, again, 2 more years later, We can't imagine any kind of world, especially for mobiles and Android, without Kotlin at all. It's like that we are in a phase where we take Kotlin for granted, regardless of from what point it actually started and how it actually moving forward. So now there are some very amazing features, especially the coroutines, because before that, asynchronous and multi-threading was very complicated, especially on Android, and developers used to often avoid those kind of tasks. So coroutines actually made a lot of things easier and simpler, and it just got a very huge adoption from developers community. So we are here at this point. So this is not completely about coroutines. I'm going to explain something more in further slides about where exactly we are and what kind of things we are witnessing at this point in Kotlin framework. So back to the original point, that why Kotlin. So if we take it from a simple language perspective, we see that it's a very expressive language. Expressive means that it does not assume anything at all, and it just asks you whether what you want as a developer. So this brings a lot of control to the developers, and the developers does not have to waste time on things which he or she does not know at all. So that's where expressiveness comes in. So other thing is safety. The null pointer exception was a $1 billion mistake, according to the creator. So safety is very important in that scenario. Even Flutter adopted it as well. So Kotlin has brought safety from day one, um, and it had actually helped a lot in dealing with those null pointer and avoiding those kind of errors in the application. Interoperability, this was the thing which actually helped Kotlin get into the Android ecosystem, because if you are learning something new, and then you must be thinking that oh, I have to start everything from scratch. So that's where Kotlin comes in. It does not ask you to do everything from scratch. Even if it's for one file, you can add in Kotlin, and whole other project is in Java and any other language. So that's also completely fine for Kotlin. So that's where actually Kotlin showed its true power, that it can blend in and it can support you at any kind of stage in your projects you are in. So after that, final is a structured concurrency. As I shared about coroutines earlier, that structured currency is all about that coroutines. Kotlin brought some very interesting features which help developers do multi-thread tasking and multi-thread programming very easy with coroutine. So that's structured concurrency is all about. So there are something others that it's a Google preferred language if you are into Android, and it's statically typed. So there is no black box thing. When you run the application, you know what's going to be run and how it's going to behave. And there is type interference, that's very important, especially when other languages assume that you are typecasting completely automatically. So Kotlin does not allow you to do typecasting automatically. It asks you specifically that what kind of typecasting you want, and this helps you at the compile time, not wonder that what happened into the runtime. So again, it's created by JetBrains. JetBrains, in my perspective, is the company which is creating compiler for like more than 20 years or something. So I think creating a language for them is a very amazing fit, because they know what kind of market they are in and what kind of things they like. So uh, Kotlin was born into that perspective to address those problems faced by developers, and to leverage the experience of 20 years of compiler construction. So Kotlin is very concise as compared to Java. Java is quite verbose, and Kotlin is completely exchangeable and integratable with Java, and again null safety and many others more. So that's what Kotlin is all about. So if these things does not convince you at this point that you why you should still do Kotlin, then we are going to move further and explain it a bit more. So, for example, we have a lot of POJO objects in Java code, especially when we are getting services integrated into the application and we are getting response from network. So, this is how simple POJO looks like in Kotlin. So, there is also another feature which you must be aware of already that if you copy any code, any Java code into any Kotlin file, it automatically converts into the Kotlin. So this is what's happening here, and you can see that how much short Kotlin is as compared to how much verbose Java is. So so we have multiple tools at this point. You can use Android Studio. You can use IntelliJ for any other projects not specifically targeted for Android. And you can use VS Code. You can use NetBeans, and you can even use command line. So there are plenty of tools at this point available for doing Kotlin programming. So for example, let's look into the some of the features and Kotlin provides. So I am assuming this with Android background. So this is a simple activity in Kotlin code. So first thing is that we see here is a nullability in the system that bundle is a nullable with a question mark. So that allows us to safely and consciously use this variable, and it helps us avoid null pointer exceptions at runtime. So then we are seeing the lambdas here. These are sort of interface callbacks, but with a much better and much shorter accessible syntax as compared to Java. Then we are seeing here an extension function. Extension function is sort of doing inheritance without doing inheritance. So it also helps a lot by adding function inside some other classes. For example, here capitalize is an extension function on string. So then we are seeing a template expression. Then like in Java, we had to wrap this hello inside the apostrophes, and then we had to add plus, and then we had to start and other apostrophes and quotations. So Kotlin allows us to do this sort of access of variables outside the string through template expressions. And then we are here seeing the property access. It gives us getters and setters automatically, so we don't have to create any. So these are some of the features which I have managed to show in one screen of code. So there is a lot of more data classes, extensions, Elvis operator, and my favorites are null safety, operator overloading. Then we have DSL support. Then we have coroutines and ranges and inline functions and seal classes and delegation. Delegation is a very interesting concept from Objective C and C Sharp. Uh, so that made its way to Kotlin, and it has really helped a lot in dealing with a lot of things, especially in Android development. So yeah. So now you are like, okay, these are the features, but what next? Like so. Surprisingly, at this point, Kotlin is about this. That Kotlin supports. Kotlin is not a language for only Android now. Kotlin is also working server and desktop development, and I mean from desktop is Mac, Linux, Ubuntu, and Windows. Every desktop. So it also allows you to do browser development, and it also integrates with existing Node.js and Reactive.js reactive framework completely. So again, we are repeating that you don't need to do everything from scratch. You can integrate Kotlin into your existing JavaScript projects quite easily. So yeah, and then there is a native layer as well to directly deal with hardware, and also it supports iOS as well. So it's interoperable with Objective C, and it plays quite nicely with Swift UI because Swift and Kotlin are almost similar in syntax and features and those kind of things. So Kotlin is now everywhere, literally everywhere. So you can run application on all platforms with a single code base. So this is not a cross-platform, as you must have seen in Flutter and React Native and those frameworks. This is actually multi-platform. So I will explain it little bit later about that what exactly is cross-platform and what exactly is multi-platform. So so this is the movement which we are witnessing about Kotlin, that Kotlin is going to be everywhere. So now, if we look only at mobile development, because my experience is in almost uh, in mobile development, so that's what I would like to talk about. So when we think about native application and we say, okay, this is a native application, and we have to maintain separate code bases for each layer. So the part castle is like this, and we think that if we use any cross-platform framework like Phonegap or Adobe, which are almost dead, and then we have React Native, and we have Flutter, which is going very hot at this time. So we think that they are like this, but in fact this picture is completely reverse. Like when you are using any cross-platform framework, at start you will see a set part, but as your project gets more complicated and it adds more and more features, then it starts to become a maze, and it starts to create some serious issues, and at some point you might be forced to rewrite whole thing from scratch in native. So I still believe in native development, and I still feel that native is not going anywhere, regardless of how much powerful multi-platform or cross-platform framework become. Because history says it all. We have this thing in history that whenever Android came, iOS was already in the market 1 year before. So whenever Android came, this race started to happen. That every year from 2006 to 2022, every year there was at least one thing new, which would like provided a new solution to the cross-platform approach. So but I think that why every year there is something new, uh, trying to solve the problem which every other company already knows. Because even after about 10 to 15 years, there is not a perfect solution for cross-platform development at this point. Probably in the next year or so, we will see something new completely. Probably people will forget about Flutter, or people will forget about Kotlin multi-platform, and there will be completely something new. But the root cause is that there is no 100% perfect solution for doing cross-platform. So it's all about opinion, and it's all about what your requirements are and what kind of projects you are trying to create, and how much budget you have, and how much it can help you with developer productivity. So, but if you think that whatever framework can become very amazing, very powerful, then native is going to be dead, or native is going to slow down, and native is going to completely lock down. So then that's not how it's going to work. So that's how it is. So you saw the whole history about how Kotlin, how cross-platform tools have come in. So I would like to bring some perspective on problem they are solving and what problem they couldn't solve. So firstly, we are seeing at advantages that we have faster learning curve, we have smaller team size. One developer is doing development for two applications at the same time. And so it also reduces our cost compared to completely native and two developers, two framework, two APIs, and double double working hours. So those are definitely advantages. But are those worth it? That's a real question you need to ask. So so that's about like if you are choosing any kind of cross-platform tool, whether it's React Native or whether it's Flutter, then you are tightly dependent on that framework. So if Android or iOS native introduces some new features, then you have to wait for those features to be ported into that native framework implementation. Like if you are using React Native, then you have to wait that when React Native starts supporting those features. So there is a gap between how things are in the native development and how things are in the cross-platform development. So there is always a gap. Community support tries to minimize that gap and tries to help that, but there is not a scenario where you see that gap is 0% and things are completely aligned on both sides. So that's one major problem. Then we have performance. Uh, since the code is completely not native, so there is always a pitch between your kind of framework and between native layer. So that bridge is the thing which every other platform tried to solve it in all these years. That bridge is the actual USP for those cross-platform tools that they claim that they can provide you a very fantastic kind of performance in your application, and their marketing and copywriting is always like your application exactly like native. Your application will be close to the native. So I think we should need to learn from this language alone that they are trying to reach a point of native. So at the end, native is a king. So then we do not have any perfect scenario where we don't have to write any completely any partial or some part of the code in native. At some point we have to write native code for both Android and iOS, and uh, then that code is also not going to be completely perfect, or it's going to be bring some more problems. So this is a rabbit hole at this point. So, like I said in the previous earlier, that new update from OS will take time to be written in the cross-platform. So, those are some of the disadvantages. Now, you are thinking that if I am advocating about native development so much, then why I am taking side with Kotlin multi-platform? So this is where Kotlin multi-platform comes in. Kotlin it's not cross-platform; it is multi-platform. So now we are going to see these problems and see that how Kotlin is actually solving these. So okay, before I go to that, uh, I just mentioned about a bridge here. So this is how a cross-platform works. So this is your app which is in native code, and this is the platform, Android or iOS, and these are the widgets like buttons and views and all those. And this is canvas and events. So canvas is for drawing those widgets, and events is for click listeners and all that. Then we have hardware layer where we have location, Bluetooth, audio, sensors, and whole kernel, BIOS, and everything else. So if you are writing a code and that is not completely native, then there is going to be a bridge. which is understanding this language and translating into your language, whether it's JavaScript for React Native, or Dart for Flutter, or C Sharp for Xamarin, or any kind of language you are targeting. So this bridge is the actual solution of cross-platform. So Flutter took this a little bit differently and tried to handle it with more gracefully, and it actually moved this whole OEM widgets block to here, and it just does not rely on OS's actual widgets. It actually redraws them completely same by itself. So it gets the control of the whole canvas and says to the OS that you don't have to worry about anything. I will handle it myself. So this is the actual reason that Flutter got so popular, and Flutter brings a very advanced kind of support in cross-platform. So this picture is from an article I wrote at my website. It was titled as "How is Flutter different from uh, other cross-platform tools?" So in that, this thing is going to be explained in very detail. So if you want to know more about it, go ahead and read it. So now we are going to see that Kotlin multi-platform is going to do what. So number one thing, Kotlin multi-platform is called multi-platform because it's not going to do any cross conversion between this. This is not a cross-platform tool; it's a multi-platform tool. Multi-platform means that Kotlin does not uh, ask you to convert any kind of existing code from one language to other. Rather, it says that the original goal should be to share the logic and not the UI layer or hardware layer. So iOS have certain rules and guidelines. Android have material design and some other guidelines. So as a platform, you need to respect those because users are more aware of those, and they expecting that your application will behave according to the OS guidelines. So converting one platform to other platform brings uncertainty to your application and sometimes misbehave. So Kotlin says do separation. You don't need to write same code for both platforms. You just write share logic, and UI layer will be separate for both Android and iOS. So we are going to see that how that's going to benefit us. So these were the disadvantages of a cross-platform tool we saw earlier. Now we are going to see that how uh, multi-platform is going to handle those. So first problem we had that tightly dependent on native framework. So every platform specific thing like Android and iOS is developed completely native. So we don't have any kind of conversion and dependencies on frameworks because we are doing completely native things. Then performance is affected due to bitch. So there is no conversion, so there is no bitch. So performance is exactly same which is in native application. Some native codes need to be written. So yes, you were writing some native code in cross-platform as well. So you will be writing some more code in native multi-platform as well. So new update from OS will take time. So since you are not using any other language for conversion perspective and for doing things simpler and in short time, so you don't need to worry about OS updates. You are respecting OS, you are respecting OS guidelines, and you are completely sync and aligned with the OS itself. So whatever comes in the OS, you have access to that on the next day. So that problem is already solved. So one of the major advantages of Kotlin multi-platform is that number one, Kotlin has huge community support and is the most trending language at this point. And low risk because it's you in your power that what to share with platforms and what not to share. And you have consistency because In completely native development, we had to write same logic on iOS and Android and web and other frameworks, other targets separately. But you have now shared logic, so you are writing it only one time, and that business logic is shared across all the platforms. So this brings you a lot of consistency. So then Kotlin at this point supports almost every major target, and there will be probably some more. So if you see from weather production perspective, then Netflix is using this for their Android and iOS app. Careem has completely migrated their Captain app, Rider app for in the Kotlin multi-platform. VMware is also using, Autodesk is also using, and Kotlin itself is using Kotlin for JetBrains Space, which is a sort of alternative to Jira and all those things. Uh, Platform which they are selling, and that's completely written in Kotlin from back end to front end to mobile app to everything. So this was their JetBrains way of not telling that this language is very awesome, rather than showing that what this language can do. And then companies started adopting it once they saw that how much powerful it is. So let's take an example that we have Android application, iOS application, web application, and desktop application. Now, usually what happens is that you have UI for those applications completely separately. So Android is using XML and Compose, iOS is using storyboards and Swift UI, web and desktop are using HTML, JavaScript, and desktop could be using Electron, desktop could be using Windows development, and any kind of tool you think that you should use. So we have duplications all around the page that we have to create almost same UIs over and over again for separate platform. Then we have business logic. So we have network layer, and we have parser for JSON parsing. We have model files for everything. So for Android model files in Kotlin, then for iOS model files are in Swift, and similarly. And then we have presenters or VM logics or any kind of architecture you are using. So this is actually business logic which is getting repeated over and over and again. So what we wanted to do, that we wanted to do this logics right once only. So that's how we actually applied cross-platform, and we thought that we will only write it once, and then cross-platform will ship it to their own. But the problem was that UI was already inside this box, so cross-platform became dead. But Kotlin multi-platform thinks it a bit different. Like this was the logic. So Kotlin says that I am not interested in your UI layer. I'm not interested in your hardware layer. That's up to the native completely. I'm only interested in your business logic, which is getting repeated. So why not just do it same? So this now becomes common and shared code, and this get uh, this is written in Kotlin completely, and is used around all platforms. And the UI and native layer is completely, mm, separate and respecting actual native layer. This is how Kotlin multi-platform native applications behave. So you are thinking that how can different platforms can communicate with this code? So this is how it looks like. That you can see that we have Kotlin Android, JVM, and Kotlin Native. This is actual platform, and then we have library, shared business logic, and UI, and all other things. And then we are actually sharing only one part, that's business logic. Okay, so we have expect and we have actual. So write something like this: expect object platform in the common folder, and this is a shared folder which will deploy on every platform. So you say that we have expect object with a name, and then we have to actually define actual on all other targets we are focusing. So for example, in the Android we will see that, okay, import the build manufacturer from Android OS package, and use that actual wall name. And in iOS is using some UI device separately, and it's written in iOS main function. And in Java, it's using the navigator and user agent telling that which browser its website is, and that's in JS. So whatever platform we are targeting, that's where this function deploys. And otherwise, Kotlin share logic will treat all those expect methods and assume with those that there will be some kind of implementation at some point, platform specific. So this is how it will look like when we run it, that every platform is treated completely identical in a way, but without compromising any kind of native performance. So this is how the code is going to be compiled. So we have common package, and that we have expect file, and then those are actually compiled in actual files, and then along with those files which are comes with the platform. So Android is dealing with jar files, and Apple is dealing with Swift and framework files. JavaScript is dealing with npm packages. But this is the thing which you actually wanted to share from day one when cross platform came up, and now you can do it with complete support of native. So uh, as soon Kotlin moved back a lot, Java also tried to catch up with that and brought a lot of features which Kotlin provides in Java 8. But again, Kotlin is now very far ahead in terms of Java. So uh, Kotlin is still amazing, and Kotlin is still super powerful, especially when it has broad support of multi-platforms. So these are some resources, and thank you for listening. I hope you like my session. So please do ask me any questions if you have any.
Thank you so much, Wajahat, for uh, taking time out to have such wonderful session. So I would just like to have this Q&A section is open. If you have any question, please feel free to drop in Q&A section or chat section. Wajahat is with us for like next 5 minutes, I guess. So please, you can drop in your questions. Thank you.
So I saw a question from Mohan. So is Swift connected with Kotlin class and function? So was saying that no, Swift is not connected with Kotlin class. Kotlin is used for dealing with all your presenter layer, and dealing with your repository layer and the databases and network layer and all those things. Swift is only will be used for your iOS application UI rendering. So not Swift will be used, rather Swift UI will be used completely as we do Jetpack Compose. So there will be no connection between Swift and Android Kotlin. If I have Swift UI, then how do I connect Kotlin logic? Is Swift support that or any other option for that? Yes, there are some very good examples. There is a guy called John O'Reilly. He has done some amazing work on Kotlin platform. I am sharing the link here in Q&A. He has some very good samples which are written in completely in Kotlin multi-platform, and they are deployed on Android, iOS with Swift UI, and those to get to know more about it. And if you are only focusing on Android and iOS, then search about KMM. One is KMP, Kotlin Multiplatform, and there is KMM, Kotlin Multiplatform Mobile. So KMM is about using your Kotlin code in Android and iOS. So IntelliJ provides some very good, nice tools about that, with integration with Xcode and all that. And if you want to improve it more to web browsers and desktop, then you can also extend your KMM project. And if you want to do it from start, then you can directly start with KMP project. So IntelliJ IDEA and Android Studio and Xcode all support KMM very good way. So at this time, KMM and KMMP is not completely stable. They are in beta, and they will be stable in 2022, probably June or July.
Thank you, Ajad, for answering the question. If you have any question, please feel free to drop in Q&A section, or you might just like if you want to put it into general chat box. Ajad is here with us, and we are pretty much on time. Okay, we have another questions coming in. Okay, all the presentation shared. Okay, Ronit, I will definitely try to take it from Wajat and those who have attended. I will try to
Ye-
manage.
Yes, my all presentations will be available on my speaker deck profile, and also if this video gets recorded, then this will also be on my website at
Hmm.
this page where you can see all my previous talks and videos as well.
Okay, let me share Wajat Careem, your website link here as well. So we have, you can find it here. I'm pasting the link to that as well. Okay, Ronit, here is the link, wajatcareem.com. So if we have, okay, Wajat also. Thank you, Wajat, for sharing this resources. Appreciate it. So if you have any other question, please feel free to drop in, and we would like to definitely would like to encourage you to get connected with Wajahat on what and his Twitter and also on wajahatkareem.com. So you can just check his all profile. It was such a wonderful session. Thank you so much, Wajahat, for taking time out, and thank you everyone for taking time off and be with us. And this hopefully this helped you a lot. And I've also put the a link to our Jumpstart event, which is on 7th of April, which will guide you towards the 80% process of vetting process of Turing. So see you there. Thank you so much, Wajahat. We are pretty much on
Thank you,
time.
Refa. Thank you, Turing, for inviting me. It was really good. Thank you.
Thank you.